we are going to kind of look at something called the compare and contrast scalar and vector quantities. Okay, so we're going to start talking about what we call a vector here today. Okay, vectors. And we're also going to describe what a displacement is today as well. Okay. Now, hopefully, it's a good thing you're here today because, like I said, today can be a little bit confusing, although it's not that bad, but we really need to understand the difference between scalar and vectors and this new word called displacement today, okay? Because we're going to be using these things going forward here, of course, okay? So it says here this, scalar and vector quantities. All quantities in science can be classified as either a scalar or a vector, okay? Those are two terms that we probably should be familiar with here, hopefully, or at least by the end of today. A scalar quantity is one that only indicates the magnitude, which is a fancy word for saying how much of the quantity, okay? Here would be some examples, okay? If I went a distance of 2 meters, 2 seconds, the speed of 1 meter per second, okay? It only includes the number, basically, okay? That's what a scalar is. It only includes the number, the magnitude, how much, okay? Now, a vector quantity, okay, I'm just going to erase this stuff here. A vector quantity indicates the magnitude, so basically, again, how much, I can spell here, how much, and the direction of the quantity, okay? So a vector quantity is usually written with a symbol, or a vector arrow shown above the symbol, I should say, okay? So, for example, now you're going to see these examples here, okay? And you're going to see a little bit of different words here. Okay, so again, what was I going to say here? Am I still recording here? Yeah, okay. A vector quantity is written with a vector arrow above the symbol, okay? And here's some examples here. Now, you'll notice these words look a little different than ones we've used so far. We'll get to that eventually. Today, we're going to talk about displacement. Now, displacement, you'll notice here, has not only a number, so not only a quantity, but also a direction. Number, quantity, direction. Number, quantity, direction. Okay? So that's what a vector is. It includes a number and a direction. Okay? And this arrow, okay, now you've seen delta D before, and it stood for distance. Okay? Now, when I put an arrow above it, it's going to look like this. Okay? That implies it's actually going to be something called displacement, or it's going to be a vector. So we want to include a direction with it. Okay? Let me just go back here for a quick second. If I said, here's the distance, is 2 meters. Okay, that's how I'd write that, of course. That's what we've been doing. The change in time, okay, is 2 seconds. That's how I'd write that. The speed, okay, is 1 meter per second. That's how I'd write that. When we talk about vectors, we put a little arrow above it, okay? And you might also see this, which is kind of just a, that's also a vector, of course, okay? So you might see that. If you look at velocity here, now you say, well, we did do v. Yeah, this one would be v with an arrow above it, velocity, okay? And we'll explain the differences here as we go. When we talk about acceleration, acceleration is going to be the letter A, and I'm going to put a vector above it, okay, because it also includes, the reason I put the vectors there is because it includes directions, okay? Is there any questions about any of that so far? Anyone? Okay. Now, what is the difference between distance and displacement? Okay, and the answer is To be honest, not a lot. Okay, well, I shouldn't say that. Not a lot as far as what it looks like, I guess, but there is a difference between distance and displacement. Distance is a scalar quantity. So again, we talk about, the distance is 40 meters. The displacement, okay, slightly different word, displacement, and by the way, this should have an arrow above it there. I don't know if yours does or not. Yeah, I think it does. Is a vector quantity, and of course, because it's a vector quantity, it includes magnitude and direction. Okay, so let's please write those two things down here. This is just the magnitude, the size. This is magnitude and direction for a displacement. That's the difference between them. Okay. So displacement is a vector quantity, and it includes a measurement of the change in distance and the direction. Okay. And here is kind of the difference between them. You have this in your notes. Hopefully you can see this. But the difference is quite, like I said before, I kind of misspoke, I guess. There is a bit of difference between these two, of course. Distance is basically, like I said, just a number. Displacement is a number and a direction. Okay. Always think of it this way. Displacement is the length and direction, length of direction of a straight line between 2 points. Okay. And the example I gave you here was this one here. Okay, which you guys have in your notes there as well. And this would be the difference between the two, okay? So the distance is like, for example, okay, I'm going to go, I'm going to travel, I'm going to go to 7-Eleven, okay? And obviously not from school here, but maybe like from your house, okay? Well, you might have to take a pathway to get to 7-Eleven, and it might go like this, okay? And you might have to curve around some houses here in a cul-de-sac or whatever kind of thing, and then you finally get to 7-Eleven here, okay? That's the distance, okay? That's how far you've traveled. The displacement is simply defined as a straight line between where you start and where you end up, okay? So to get the displacement, you'd have to get like maybe a little mini helicopter, okay? And you'd hop in your little mini helicopter and you'd go, well, straight, basically, right over top of all the houses, right to 7-Eleven, okay? That's kind of the difference between distance and displacement, okay? But here is, this doesn't actually quite, this does a pretty good job of that, but it's also, let me talk about this. If I start here, and we'll call this point A, and I go, let's say, to this point here, I'll call it B. And then I decide to turn around and go to point C. So I decided, you know what, I went and picked up Bobby Joe at B here, and then I went back to Conrad's house at C. Okay? So when I look at this question here, and this is kind of what I'm getting at for today here, if I looked at this and I said, okay, how far is it from A to Bobby Joe's house? Let's say it's 400 meters, okay? And then I decided, okay, well, we got to Bobby Joe's house, but now we want to go pick up Conrad for a little PS4 session here at Conrad's house here, and that's, let's say, 100 meters, okay? I know that's not quite the scale there, I get that. The distance in this case would be 500 meters, okay? So this is kind of how far you would walk. This would be 500 meters, okay? Does everyone understand that so far? Is everyone okay with that? Give me a yes or a no, please. Somebody else. Come on. Is everyone okay with that?
Yeah.
Okay.
Yeah.
Now, here's the thing, okay? Let's say, slightly different scenario here, but let's say this person here at A, I didn't give them a name here, I guess, let's say they just decide, hey, the person at A, what's an A name here? Avery. Avery decides just going to go to Conrad's house to play PS4 here. Well, Avery doesn't really have to go all the way to Bobby Joe's and then come back to Conrad's, okay? If Avery just wants to go to Conrad's, this is called the displacement, okay? So this is kind of where starts here, finishes here, okay? This right here is the displacement. We'll talk about how you figure that out, et cetera, et cetera. It's not only a number, but it's also going to include a direction. And that's what this is right here. Make sure you know your directions. I know that sounds stupid, but you should probably know the directions, okay? North, west, east, and south. Make sure you know which way is which, okay? Write that down if you have to. So, again, if Avery's distance here would be this and this, so that'd be 500 meters for the distance for Avery, okay? We could probably pretty easily figure this out, but if Avery just wanted to go to Conrad's house and end up at Conrad's house, that would what? Be about 300 meters, yes? With a direction, which we'll talk about in a second here, okay? Is everyone okay with that? Yes, no? Ask. Say yes or no. Okay. So, how do we calculate the displacement, basically? How are we going to do that? Okay, well, I'm just getting the same notes as you guys have here just to make sure. Well, to calculate the displacement, we're going to add up the positions of each vector, basically. Okay, now, this is going to sound kind of silly, okay, but we're just going to, there is a reason we're going to do this for down the road here, okay? So it says here, make sure you assign one direction as a positive. One direction is going to be positive, and the opposite direction is going to be a negative, okay? So for example, up could be positive, down could be negative. We could let west be positive. We could let east be negative, okay? We could talk about south is positive, north would be negative, okay? And we're going to kind of use this little thing right here to decide, okay, what's the overall displacement of these vectors, okay? So, here we go. This is your first example here. Is this one done already for you guys on your sheet or no? Do you guys have the answer for this already? Yes or no?
Yes.
Okay. Yeah, okay. Well, unfortunately, you can just kind of follow along then for this first one, okay? Now, and I'll probably, actually, I might do this in two parts here. Well, no, I guess I can't because it says, yeah, it says this. Well, I can still do it, okay? So it says assign east as being positive here, but let's just take a look here. A student walks 200 meters east, okay? Now it says right here, we're going to assign east as positive. So I'm just going to put a positive right there, okay? 200 meters east. And then turns 100 meters west. So that's going to be a negative because I'm going in the opposite direction, okay? What is the total distance traveled? Already, we're starting with what's the difference between distance and displacement. What's the total distance traveled, somebody?
200.
Sorry, I didn't hear the first part.
200.
300?
Yeah.
Okay. So the total distance traveled here, let's just write that down, is 200 meters plus 100 meters is where I got that from, or 300 meters. Notice the terminology, the distance, okay? This is back to basically, and I don't care what direction we go in. If I got to go 200 meters east, okay, 200 meters, by the way, if you're in the classroom, we'd be heading out into the field, yes? Okay, so we're going out into the back parking lot here, 200 meters, and then we turn around and go 100 meters back towards school, and we're not going to quite reach school, of course, but that's 300 meters we've walked, okay? If you did that on your old Apple Watch there, it would give you credit for 300 meters of walking, okay? That's the distance, Okay. What is the student's final displacement, though, is the next thing. And it says here we're going to assign east as being positive. So we say, okay, well, the displacement is equal to basically the displacement. What do they put here? D1, I guess, yeah? I guess I don't need the sign here. It's just to kind of keep it the same as you guys there. And D2. So I'm basically going to add those two vectors together, okay? So they said, hey, let's let east be positive. So I'm going to say 200 meters east here, okay? And they're going to put little brackets here because that indicates the direction there, okay? Now, I'm going to add these two vectors together, so just be patient for a second here. And I'm going to put 100 meters west, okay? Just like they did on your sheet there, okay? And they're going to say, okay, now let's go ahead and actually add these two together. Well, this east is a positive 200 meters, okay? And in fact, okay, you may want to consider doing this. The east direction is a positive, so I put a positive here. Now, I know that's not on your notes there, so just pay attention here, okay? This 100 meters is in the west direction. And if we said east is positive, then the west has to be the opposite direction. It has to be a negative. Okay? So when I add these two numbers together, okay, and what I've done here is I've kind of replaced the east with a positive, and I've replaced the west with a negative. Okay, and I'm going to get rid of that because that looks a little confusing there, but okay, and when I add these two together, I get a what? I get positive 100 meters. What does that mean? Well, it actually means this. 100 meters in the east is positive direction. Okay? So notice the difference between these two answers. This is the displacement. Is there any questions on that, anyone? Questions? How are we doing so far? Good? Yes? No? Now you might say, okay, how do I know which one's positive and which one's negative? And the answer is, it doesn't matter. Okay, you pick one. You know, does it work a little bit easier if you pick one of them as positive and the other one as negative? Yeah, it definitely could. Okay, usually, you know, the bigger number, let it be positive kind of thing, but sometimes you may not know because we have a few vectors to add together. So what happens if you did the opposite of this one? So this is where I want you to pay attention. You can even write this on your side here if you want. What happens if you said, let west be positive? How does this change now? So I would start with the same stuff here, D1 plus D2, okay? Those vectors, basically, those displacements, okay? Now, I said 200 meters. That would be what, east here, and I'm going to add on to that 100 meters west. Okay, I'd start in the exact same spot here. But if we let the west one be positive, I'm going to keep this as a positive 100. Okay, so that's a positive 100. That means in this case, the east one has to be the negative. So this would be a negative 200 meters. And if I add those two numbers up, I get a negative 100 meters. Okay, that's my overall answer. Well, what does negative 100 mean? It means I went 100 meters. Okay, now remember, west is positive. My answer is negative 100, so the negative has to match up with what? East again. Yes? So if the west is positive right here, and I end up with a negative value, well, I guess that's not positive, that's not west, that's got to be east. Okay? So I get the same answer, it's just, you know, might be a little bit more confusing perhaps or whatever, but I'm going to get the same answer. Okay? So if you're worried about which one's positive, which one's negative, it doesn't really matter. Okay? Now you might say, well, do I have to show all this work? And the answer is, well, you should be familiar with positives and negatives because this will apply to later lessons. some of you are going to be like, well, let's see, 200 meters west. What does that look like? If I get the old northeast, west, south here, okay? This way's east, so I'm going to draw a little vector here. You know, we can also kind of look at it as a picture here. I'm going to go 200 meters east, of course, okay? If I turn around and I come back 100 meters in the west direction, okay? Again, 300 meters distance. Where did I start? Where did I end up? Where am I from the starting position here? Okay, this is my starting position, my zero basically, my reference point. Okay, where am I? Well, if I went 200 this way and I came back 100, I guess I'm 100 meters here, yes? And where am I from my original position? If I start here and go right to here, I'm 100 meters in the east direction. Okay? Is everybody okay with that? Yes or no? Speak up.
Yes.
Other people?
Yeah.
Okay.
Yeah.
Sydney?
Yeah.
Okay. Speak up if you're not, because again, this is really important that we know, because if we can't calculate this, we can't calculate the rest of these formulas basically for the rest of this unit. Okay? Well, a lot of them anyway, for sure. Okay? So that's kind of what we're doing with these vectors. Okay? Let's look at example 2 here. If a student walks 500 meters north and then 200 meters south, what's the total distance? What's the student's final displacement? Okay, so same question basically, right? Well, what is the distance? Let's take a look. 200 meters and 500 meters, okay, is 700 meters. That is your distance. Okay, done. Easy. Okay, 500 meters north, 200 meters south. And if we were in school here, we'd be going 500 meters towards the church, of course, probably past the church, and then 200 meters back. Okay. Now, you know, we can draw a vector thing too here, right? Okay, so 500 meters this way, north, turn around, come back, what, 200 meters south. Okay, where am I from where I started? I started here, I went up, and I came back down, basically. So the question becomes, where am I from here to there, right? This is what we call the displacement. So to do that mathematically here, I'm going to call this positive and I'm going to call this negative. Okay. So north is going to be positive. I pick that. You can pick the other one. I'll say here, let north be positive. Okay. And again, if we're looking for the displacement, we're going to take D1 and D2, which are the vectors that we're talking about here. Okay. The displacements, the two displacements that I have. So 500 meters north, and I'm going to add to that 200 meters south. Okay. Then I said, okay, north is going to be positive, so positive 500 meters. Negative for south, negative 200 meters. Okay. Notice I kind of took the direction off, but I didn't really, because the direction is kind of built into this right here and here, right? I mean, that's the direction still. So I still have it there. I just chose not to use north and south. I'm using a positive and a negative. Okay? If I add these two together, I get a what? Positive 300 meters, yes? And a positive, of course, is 300 meters north. So that's where I would end up. That is my displacement. Okay? Questions, anyone? Yes, no? Are we good there? Gonna move on? Okay. All right, moving on. And we might stop after this so we'll just take a look here, but I'll take a quick look here after this one here. So I want you guys to go ahead and kind of give this one a try here. Let's start with this, okay? Let's assign a value to one of these. And I don't care which one you decide, which one's going to be positive and which one's going to be negative, okay? You decide. All right. You know, and honestly, if you wanted to, you're going to notice that we always do opposites. So if you're going up, then you're going to be going down, kind of thing. Okay. If you're going, you know, west, you're going to be going east. Okay. We don't do not in Science 10. We don't do any of this. We're going north and then east kind of stuff. That's probably Physics 20, I imagine. Down the road here, okay? And then you'll use right triangles and things like that to solve for vectors, okay? All right, so go ahead and get a start on that there. You know, again, you might want to look at this right here, total distance traveled by the athlete. What is the total distance here? Somebody? What is the total distance, somebody, please? Total distance.
6 kilometers.
Thank you. 6 kilometers. I'd probably call it 6.0 kilometers. Okay. So we're just going to add those distances up. Yes. 2.5, 0.5, that's 3, and another 3 is 6. Okay. So that's the distance. So that's one answer. Okay. Easy enough. And then if I want to do the displacement, in this case, okay, we're going to take D1 plus D2 plus D3. We're going to have 3 vectors we need to add up here in this case. I'm going to let, I decided I'm going to let west be positive. And, okay, let west be positive. And the only reason I did that is because, well, west showed up first, you know. But here we go. So I'm going to take 2.5 kilometers, and I'm going to do this in the long version here. And I'm going to add to that, what, 3 kilometers east, and I'm going to add to that 0.5 kilometers west again here. And again, this is now where I would substitute in positives and negatives for directions. So this is a positive 2.5 kilometers for me. This is a negative 3.0 kilometers because it's east, and this is a positive 0.5 kilometers. And if I add these up, what do I actually get here? Somebody? What do you get? Somebody, quickly. Huh?
0.
That's right. 0 kilometers. Okay. Now, this is the kind of one exception. That's why this example's here. Okay. Now, is this a positive 0 kilometers or a negative 0 kilometers? And the answer is, well, it's neither, yes? Okay? So, in this case here, okay, we actually will not have a direction with this one. This is the only time this happens. And the reason is, of course, look, technically, okay, if you went 2.5 kilometers and then back 3 kilometers and then back to 0.5, so you do all this stuff. Let's see, which way is west here? So 2.5 this way, okay? And then I went, what, 3 kilometers this way. And then I come back to here, 0.5 kilometers, okay? I started here, and I ended up here, right? So technically, you actually haven't, according to displacement here, you actually haven't gone anywhere, okay? And that happens sometimes, okay? So remember, distance is the amount that you've traveled. Displacement is from where you start to where you end up. It's a straight line between those two. Well, technically, I started at my reference point here, and I ended up here. You know, I didn't go anywhere. So that's the difference between distance and displacement, of course. You may end up not going anywhere. Okay? So displacement is always from where you start to where you end up with. Like today, for example, okay, well, maybe I can't really use you as an example, but for me, okay, I actually drove today here, but I drove to school today, okay, so that's that's some vectors that are involved with that. I have to go pick up my kid after school from school, or what did I say? I have to go pick up my kid after, from school. We're going to golf lessons, okay? And then eventually we're going to get back to home. And if I started at home, say, hey, this is my reference point, after all this traveling here, my displacement is going to be 0, okay? Or at least I hope so, okay? So that's kind of what we're talking about here. That's the difference between those two, all right? Any questions there, anyone? All right. Okay. So today, I think that's probably enough for today here. So let me just, or do we want to do the graph too? What do you think? We got 10 minutes left, eh? Do we have time for the graph? Nah, you know what? We're going to leave the graph. You're welcome. All right, so today, for homework here.